Okay, I'm gonna put together my robots, my servos, to see if I can create a nice little robot, little buddy pile. I need somebody to help me around. So I did. I create the self-balancing and made little toes, crooked toes for the bottom. And as far as the legs, I have the bending part and segment. This first time I'm working on it. I have the outside for moving in and out, and for walking. I don't know how long this bot is. I have not decided. I have not measured it. I just did it out of regular cognitive skills. I can move it, the legs, like that, and get a little light to it. Move the legs like that, in and out. Self balance. Move the toe, bend the knee, upward, walking like that. This is about 25 kilograms, like 60 kilograms for central for the waist. I'm going to use another servo behind here to turn the torque to race. I only made a temporary connection linkage between these two brackets. The arms, I have the arms configured right here for the shoulder to turn left and right. It's a little stuck there with my fingers, I don't know why. Okay. Okay, now I got it. Okay, so there, that will deal with the following. That is the pan, the tilt. It must also oscillate. Pan, and I believe this is pan, and then I have tilt, where I have pan, and tilt. I believe I have pan, tilt there, and the pan, and tilt. So, I guess no pan, tilt here. Anyway, but I'll get it correctly, like I'm doing the legs, and I can enable it to fold over one another, like he's folding in a chair. I'm trying to get as humanoid as possible. And my name is Morton, and I'll be back. I have more servos to offer in there to this unit. And I'll finish this device probably tomorrow. My name is Morton, and bye. I have the access for the pan for the waist, and also the tilt for the lower abdominals. I have the walker and the walker. I have also the self-balancing right here for the foot. I have the knee bend for the walker for the knee servo. I have the shoulder for the panning for crouching towards one another. I have the pan, I have the pan, and I have the tilt, and that pan actually backing up. And I have this to put the other servos in chain to link for the arms. And I have to put the central for the neck and for the head. So I'm going to do the central for the neck and for the head, and I'm going to do the arms and make adjustments on this one. So as far as that, still working on it. While working on that, my idea, my plan is if I get the motors and everything running, as far as the motors, I'm going to be adding in between and taking apart and adding between the linkage piezos, pyro crystals, piezo buzzers, and pressure sensors. I'm going to enclose this with conductive latex and polyurethane, and that's going to be used for actually thermal sensors, and I'm going to be applying some coils there too. So even though it could be encased in rubber, it still would enable it to be articulate. The idea is also to add pneumatics to guide along with the servo brackets, and I'm also going to add and I do use the conductive sensors. I'm going to add coin battery slots where I'm going to input them into alongside the servos, the 3 volt coin batteries, button coin batteries. I'm going to be using that to power the system. Each one is going to have 2 coin batteries, which enumerate 6 volts max, 6 volts max. I'm going to then coil the composite for the batteries, for the coin batteries. I'm also going to add permanent magnet powder with the conductive polyurethane and latex. Nickel neodymium powder will be added to it, so that it will create a greater magnetic field to strengthen the torque of the servos that is going to be localized within the system, the subsystem of the polyurethane exterior. Hopefully I can make this like a humanoid as much as possible, and masking and doing the foots and the toes and stuff like that, and the arms and stuff like that. So I don't know if it's going to be larger in the ass. If I have to extend the frame to make it longer, I will. And just so that the polyurethane will be smooth and look really like a strong human, like a wrestler. The conductive polyurethane magnet enclosures will enable the more stronger magnetic field. I'm also going to be using the pneumatics to assist in the driving of the walk and the driving of motion and movement. So it's exchanging between 2 cylindrical bores miniature micromagnetics. I'm also going to be using dampers and pulleys for it to return back to its orientated state, and that should assist the servo in guide for rubber bands. And that will be localized within the enclosures. I'm gonna find a way to tape around it. Get some use probably some plastic wrap and wrap up the rubber bands and stuff like that before I enclose it with polyurethane, so that it would not be stuck to the polyurethane. The microcontroller that will control the robot, and that's later on in the segment. I'm gonna add that within the system. So my name is Humanoid. Goodbye. So the other servos have to go in here, and that's really it. And I have to put the head on there. Put a temporary mount for a head, and there I get rubber the face over here, over this unit. So I'm gonna put a bracket on here, and put the servos on here, and it should work lovely. After that, I'm going to find space for the coin batteries before I even do any wiring up. I also have to find space for the SD card slot. I'm going to be using the SD card and SIM slot drive, and I'm going to be applying them to the surfaces of the servo. Each servo shall have its own SD card slot. My hope is to try to get in the 1 terabyte HDXC, and to use that for the memory and an EEPROM, which is a small microcomputer, which is going to be on the other side of the servo. And each individual servos will have their own microcomputer processor in and output. That would synchronize the memory, storage to memory, and memory storage, and also transmit and communicate with all other parts and the initial brain, which I'm going to have in the system. And that would correspond to coordinated events of the motor. Now, even though I would need a pressure sensor, so I think I'm apply a pressure sensor mechanism localized by the arm. So when turning the arm, I get to press the pressure sensor to see how much pressure I'm using to force drive on any kind of these circuits. I'm just trying to make like synthetic mechatronic nerves, and the feet pad and stuff like that, and additional segments of the conductive parts for heat and dissipation of heat sensors, and pressure sensors, wind velocity sensors, and I would try to embed a mouser type, So I'm studying the mouser and trying to find out how can I make I'm trying to find out how to make the latex that I'm going to put over here in polyurethane rubber enclosure housing and carve the indentations with my carving solder gun and melt to shape like a human body while the servos are embedded within the system. I want to create the mouser, the scroll mouser and touch scroll mouser. So I want to create that on the exterior of create that on the within the inner surface of the latex rubber. So I would have to find certain sensors to apply alongside within the system, so it detect the outer exterior within the infrastructure of the outer exterior structure, the bending deformation. I don't know if I need pyroelectric film, and to scroll and stuff like that. So I do want to scroll mouser as a synthetic skin, and I'm going to try that to learn how to create that in a further segment. So my name is Memory. Goodbye. So it's time to add on the head. Got to tighten up these things. I got the hand right here for the arms. I'll put the hands here. I don't know if I'm going to use solenoids and grippers. I want to get a robot hand for it. So there, they're curving. So I got a lot of strength to that. So as far as you see, I'm getting there. Get down my little robot. So first we turn with 60 kilograms, 25 kilograms of walking, and I'm going to add an additional gyroscopes, and I'm going to be adding mode hubs, 5010s, or 5010s, and I'm apply it right here along the side right here so I can drive the servo horn. So what I'm going to do is I'm going to use a belt so I can pull it, but it's going to be retractable. I'm going to mount it to the servo horn so that it will catch. What's going to happen is that this is going to force the drive of, even though the servo is going to be moving the horn, it's going to force the tension spring to immediately return. So I want the returner to return the belt. This will be localized along the side. I don't know if you can see it. It'll be localized along the side, which it has enough room to be right there, local to the servo horn right here, to drive that to enable it for running faster and for gyroscope. So gyroscope. So I think that I'm apply two of these coupled together, where it has a double drive, and one will be the gimbal as far as the gyroscope, and I'm trying to formate it in frontal and angle so I can keep it self-balanced and extra self-balance other than the driver, the self-balancing driver of the unit. So my name is Humanoid. Goodbye. Okay, I have the Bluetooth camera module sensor. I took the camera out so I don't have to have it applied. I don't have to apply it there. These are implementations. We're going to be addings in additions to modulate this robot machine. This little minor robot machine. And the idea right here, I have the 16 drive servo controller, servo and controller, and I have the magneto Doppler sensor. I have coin battery connections to the system. Unfortunately, I believe I'm get a cord battery cable. Here is the coin battery slot. That is about 3 volts for the coin battery. The coin battery pad, I used flexible. I used a flexible breadboard and to connect them in a chain. But I wanted to use them to distribute them individually, and that should go in the back of the frame like that. And what I'm going to do is put a plastic under it, a sheet of plastic, and what I'm going to do is hot melt it to it curves around the segment, and this is going to be mounted to the bottom of it in a chain. So that's going to assist in the enclosures, under the enclosures. Hopefully I want to also apply the wiring coils along top of it so I can synchronize the bottom and top to synchronize the magnetic field. So I probably apply a coil on there and on top, so here I can have that synchronized induction. The other idea I have is, in addition to that, I have these small little vibrator motors and vibrators, and I'm going to be using piezo buzzers to oscillate the piezo buzzer and to cause electrical energy generating back to the system. So I use the piezo buzzers to create a electrical charge back to the system and generate energy through using the vibrators, the micro vibrators. I have sets of them to continue to vibrate on the piezo and exert energy back to the power source to the battery, so I don't run my battery out. That's one thing. The following is the light sensors. This is going to be due for the head. So I have an idea for this to create 2 light sensors for 2 individual eyes and eyesight. Now I would have to do something, and I would have to add the dish, a reflective dish like this, into the system, and add that around this system. So the only output that should be visual is the light, the LEDs, and this central sensor right here. This is the color sensor actually, and that would assist in identifying the colors for the robot optical viewpoint. And the dish, I would have to make holes in it with the hot gun, with the solder gun, to apply holes to allow these to be visually exposed within the shield and within the reflective shield right back to the source, so that the light that it captures and the sensors, the color sensors, is to detect the color for the camera that I'm going to add to it. Now, the camera that I'm going to add to the eyes, because I need eyes, and these are oscillating cameras. I'm really looking for where I place them, and I really don't know where I place them at, but I'll get back to that in a few moments. The addition is I'm going to be using the wireless for the camera. I'm also going to be using the rangefinder, the coin battery charger to recharge coin batteries. This is a coin battery charger sensor. It's a 3-volt coin battery charger. We'll be using that. Here is another rangefinder sensor. This is for gyroscope. This is an audio voice command for controls for access to accelerometer sensor. And this right here. It's another sensor I have. I can add here. This is the MCU chip, and it controls the access accelerometer. I believe it's a 3-axis. I'm not sure if it's a 3-axis or 8-axis. I think it's a 3-axis. This is the Neurosky. This is another, I think, sensor, rangefinder sensor, access accelerometer, and I have the human radar Doppler. I'm also going to be adding, and that's another one sensor there. And I'm just going to be adding the cameras and coils and the cameras. I have the Arduino, I have the servo. I just got another 32 controller, 32 servo controller, and it's going to be using with PS2 controller, and that's going to be controlling the servos and stuff like that. Here, like for the coin batteries to recharge, but I think I'm also going to use piezo buzzers alongside in the frame, and that should add the electrical energy back to the system to recharge. I'm going to be using also these MOSFETs. I have small sensors. These are bipolar sensors. I have a lot of stuff to add to it. This is what I was talking about when it comes to the ultrasonic driver. This should protect my robot, because I don't know, I might want to go outside and hang out with my robot, and some dog might run up to my robot, and that's a real bad thing. So what I was going to do is I use the pin inputs, which is an AC. I'm going to be phasing this with the winding coil, phase 1, and then phase 2 in, so that the electrical, this is a piezo driver, it's actually ultrasonic, and what it's going to do is send the electrical current. I'm going to probably put a voltage booster or bypass to a capacitor and down power back to the system. So to cycle that back around, so that, you know, I can be able to keep the dogs from making my robot. You know, I really want to establish, another thing, I have to use my memory card slots, which I have to order a lot of them, so it's probably going to be like more than 32. I would need the memory card slots for the large and small memory SD cards, which should be able to hold in the EEPROM, the software-based processing to drive the SDX, which should be about a terabyte each card. So I need the terabyte card reader to read each servo individually. So it's going to be modulated each one with a breadboard, so that will send back to the system. And it will have its own, maintain its own power. So I have a lot of these distributors, which is these are 3-volt coin batteries. And these are lithium 3-volt coil batteries. So I do want to add a piezo to vibrate to send electrical energy back to it to recharge using a vibrator. So even though I'm going to have a breadboard attached to one side, but I'm going to have a power source on the other side of the servo. So once all of that's done, and then I'm going to wrap it with plastic wrap, and then I'm going to latex the entire exterior with a conductive latex. And then what I'm going to do is put some pin in to the latex for temperature sensors. And somewhere I think before I do that, I'm supposed to add the PIR sensors. So when I do wrap it with the plastic wrap, I should be able to have the PIR sensors alongside mounted within the frame, and it should emit light. So I don't know if I'm going to use PIR sensors or I'm going to use fiber optical translucent wire. So it should phase the send light through it. So that reacts as a PIR sensor, passive light sensor. So when getting deformation of the latex, it should be able to feel some type of sensory, and transmits that from the light sensors, the PIR to infrared light and passive light, and transmit that back into the system for recognition, just like it's just switch controls. The heat sensors, making the conductive, is to avoid heat, so that the robot do not touch anything too hot, and to sense it through the latex, rubber and polyurethane mix conductive, so that it does not touch, heat. It would basically respond as the heat sensor switch controls. So that's all within variables and the syntax script of Arduino. So I'm going back to finish up the robot, and I'll see you later. My name is Flymorton. Goodbye.